Hey students, here's a video for review for Spiral 3. This is updated for the 21-22 school year so that the slight changes are in the video as well. For the first one, we were given a function and we have a graph of this, and you're asked to identify some different information here. The first part is asked to identify if this is concave up or concave down. This is really a vocab question, so your goal is to figure out that concave up looks like an up parabola and concave down is a down parabola. This graph opens up, so it's concave up. The x-intercepts, again, we're identifying where these are. They're on the x-axis. We're looking for the points negative 3.816, comma 0, and negative 2.184, comma 0. The axis of symmetry, we've got to know that goes through our vertex, and it's an x equals equation. Here we have an x value of negative 3, so that's our value. The y-intercept, again, just making sure we know how to find that, 0, 25. Hopefully this is not so scary a thing for us. On the back side of this, we got a little bit of a bigger ask, which is to look at this graph and to decide whether these functions could be used to model the graph. And I always start the same way for this. I'm going to start by trying to make sense of the concavity here. Sorry about the plane going by or helicopter, don't really know which. So here we're looking at a concave down graph. That means no matter what form our equation is in, that we're going to have a negative out in front. Both of these have a negative, so we're okay there. The next thing to do is take a look at the forms of the equations I have, and in both cases, we're looking at graphs, or we're looking at equations in intercept form or factored form. So I'm going to think for a second. So I know factored form has to do with some kind of a multiplier. In this case, that's our negative, so it flips down. And we've got x minus the first root and x minus the second root. That's a little bit hard to understand in terms of the variables there. So let's think about a real example here, which we have two of down below. The minus here tells us that we're going to look at the opposite sign. So we should have x-intercepts at x equals negative 5 and x equals negative 2. These are believably those numbers. I can't really tell based on what we have here, so I'm going to go with that's okay for this one. For my other one, we've got x equals negative 2 and x equals positive 3. We don't have an x-intercept that's positive, so that tells us that we cannot use this one. So I might say something like both x-intercepts are negative, and that would be why we can't use that one. So you need some explanation there. You can't just say, yes, this is it, or you're not going to get credit for that. You need to explain what's going on here. Other things that we could use would be a y-intercept. We'd have a negative y-intercept somewhere down way below off this graph. If we had vertex form, we could see if the vertex was in the right place. An example of a vertex that would work for this would be something like y equals 4, I don't know, x plus 7, because that's somewhere on the negative side, and then plus 3, because that's a positive y direction. That gives you the idea of where the vertex would be, but we don't actually have specific numbers for that. And then the new section, we got to do some factoring. Then we got to do a lot of the same stuff we just did on the previous problem, but now we don't have graphs to work with. So let's take a look at this. So to factor this, we're going to start off by, and I'm going to make use of all the space on this page here, by zooming in. I'm going to start off by doing that a times c stuff. So I'm going to multiply my first and last number, and 15 times 8 is going to be 120. Wow, it's kind of a big number. So I'm trying to multiply it to 120. I'm going to add up to 22. Just for the sake of trying to be consistent and to show this is not magic in any way, I'm going to start with 1 times 120, and that adds up to 121. That's not what we're going for. Okay, how about 2 times 60? Well, that's 62 when I add those. Nope. 3 times 40 gets me 43. We're getting slowly closer. 4, when I divide, I get 4 times 30, 34. 5 times 24 is going to be 29. 6 times 20 is going to be 26, so we're getting closer. 7, when I try, it doesn't work. We get 8 times 15, which is frustratingly close. That gets me to 23. 9, when I divide, it doesn't work. And then I get 10 times 12. Oh, phew, that one adds up to get us 22. So I'm going to rewrite this. I'm going to rewrite this as 15x squared, and the plus 8 is going to stay the same. I left lots of room so I can do some stuff in different colors. Then we got plus 10x plus 12x on the inside. So all we did was split the 22 into 10 and 12 because that's what this suggested to us. That's the hardest part about factoring, is finding those numbers to make this work. After that, I'm going to take a look at 15x squared and 10x. Both of them have an x. If it helps to write this as like 3 times 5 times x, and 2 times 5 times x, that's totally fine. So both of these have an x. I'm going to take an x out of both and put that out front. I've also got 15 and 10, both of which are divisible by 5. Again, I can see that up top as well. If I divide 15x squared by 5x, I've got a leftover of 3x. And I can see that up top. Same thing for the next thing. If I divide 10x by 5x, we're left with a plus 2. And again, I could see that up top if I did that factoring method. For the next pair, I'm looking for what I can divide both 12x and 8 by, and that's going to be 4. So when we do that division, 12 divided by 4 is going to be 3x, and 8 divided by 4 is going to be a plus 2. That's good news because we have two things that are now the same. Those come out front and get combined into one parentheses, and the other one is going to be built from our leftovers, and that's going to be 5x plus 4. So that is factorable. If it were not factorable, a really good hint is if you cannot find numbers that work for the sum and multiple thing, that means that we're not factorable. Okay, so now we got some work to do based on this. This is in standard form. We have some tricky things that we have to work with, and I'd like some explanations for where these things come from. So the y-intercept, if we're in standard form, a couple things you might say, that's where x equals 0. So in our equation, 15 times 0 squared plus 22 times 0 plus 8 is going to be equal to 8 because those things zero out. You might also just say, oh, look, this is standard form. The 8 is going to be the y-intercept. That's fine. For the x-intercepts, we're going to use our factored form and just pull those over here. So we end up with 3x plus 2 and 5x plus 4 and have those equal to 0. That means that 3x plus 2 is equal to 0. If I minus 2 and then divide by 3, we get x is equal to negative 2/3. We get 5x plus 4 is equal to 0. If I minus 4 and then divide by 5, we end up with x is equal to negative 4/5. In many cases, the zeros are exactly the same as the x-intercepts, and this is one of those cases. So negative 2/3 and negative 4/5 would be our zeros. One of the differences is that the x-intercepts are the actual points, so it would be more correct to list those as the points negative 2/3 comma 0 and negative 4/5 comma 0. But it would also be totally fine to just leave them like that. Then we got to sketch a graph, and I'm going to include some important points here. The important points that I'm going to try to include for this, one is definitely going to be my y-intercept that we said was 8. I'm going to include my x-intercepts of negative 2/3, negative 4/5. I would love to include an axis of symmetry. I'm not going to have you find the average of fractions, though, so we'll ignore that for this problem because I chose numbers that were not pleasant. And then your parabola should be some kind of a U shape, should meet at the vertex in the middle of those intercepts and make sure it goes through your y-intercept.